In the last presentation, we completed the basic of mux tree and implemented the 4x1 mux by using the 2x1 mux. Now, in this presentation, we are going to implement the 8x1 mux by using the 2x1 mux. The method that which we will follow is the same as the previous lecture. So let's do it again. And remember one thing, I'm not going to complete the implementation of 8x1 mux using the 4x1 mux in this particular presentation because it is kind of a special case in mux tree and it will be covered in a separate lecture, maybe the next lecture of course. So it is highly recommended to you to see that lecture because you will stuck in it if you don't see how to implement 8x1 mux by using a 4x1 mux. So let me write it down. We are going to implement 8x1 mux using 4x1 mux in the next lecture. Okay, and this thing is a special case and also very important. It is very important. So let's move to the implementation of 8x1 using 2x1. The first thing that I explained you in the last presentation is to see the number of input data lines of the required mux and the available mux. So if I say N1 is the input data lines of the required mux, which is 8x1, so it is equal to 8. And if I talk about the input data line of the available mux, that is 2x1 mux, it is equal to 2. The next step is to divide 8 by 2 and it will be 4. Then again take 4 and divide it by 2, it is 2. Take 2 and divide it by 2, it is 1. Now stop. So what we are going to get by using this result is the total number of 2x1 mux required to implement 8x1 mux, and it will be the summation of these results, that is 4 plus 2 6, 6 plus 1 7. So total 7 2x1 mux is required to implement one 8x1 mux. And also it tells us about the sequence. We will first implement the 4 2x1 mux, then 2 2x1 mux, and then 1 2x1 mux. So I have already made the circuit, so let me paste it. It will look something like this. Okay, and you can see here that I have used 4 2x1 mux first, then 2 2x1 mux, and then the 1 2x1 mux. So fine. Now the important thing left is to determine the select lines. I have not written the select lines here because I will try to find out by using this table. So let's say if I want I0 as the output, then out of this I0 and I1 I have to select this thing. So I will write 0, and if I write 0 at this point, I have to write 0, or I have to give 0 to the select lines of this 4 2x1 mux. So at this point I0 is selected, at this point this I2 is selected, and at this point I4, then I6. Fine. Okay, so out of I0 and I2 I need I0, so again I have to give 0 here, so 0 here, and I0 is selected, and I4 and I6 is the input to this mux, and 0 is the select line, so I4 is selected. Again I need to give 0 to select I0, so y is equal to I0. In this way we will do the next case also. I1, to have I1 I am having 1 here, all this will be 1, and again these two are 0. So here I am having I1. So one thing you can see that in this 4 mux the select line is acting as S0. Similarly in this 2 mux the select line is acting as S1, and in the last single mux it is S2. So we will write it as S0, 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 S0. This is your S1, S1, and this is your as 2. So in this way, the implementation of the 2x1 marks is done to obtain the 8x1 marks. So this is all that we have to do in this presentation. In the next presentation, that is very important, we are going to implement 8x1 marks by using the 4x1 marks. So see you in the next one.